I mean, this could just be some bulbs out. I'm not really sure that this is why we're here. Oh, is that rolling?
Yeah.
My brother said got like left front lights are out, but it could just be a bulb. So turn signals aren't working up front either. It's blinking fast in the rear, which it would be. Get a shot of that rear.
Get a shot of your rear.
Got it? All right, now here's the right rear. Passenger rear. Blinking slower, right?
Yep.
All right, so we got some bulbs out up front. There's right turn.
Yep.
There's left turns on, and it's not blinking at all. We got no lights on the left side. This isn't even one of the cars we were supposed to be working on. What is this? So we can tell everyone, since we are filming now. I mean, it's a Dodge Charger. Don't know the year offhand. 12 of 07, so it's an 08 Dodge Charger. And Danner, did they say that the lights stopped working right when they brought it to you?
It was in for an inspection across the street.
In for an inspection?
Yeah, so the left.
Yeah, there's no lights for the left side. Well, I mean, the headlights work,
yeah,
but
there's supposed to be a side marker here.
I mean, we could just have a couple bulbs out.
I think he said they took them out and the bulbs didn't do anything.
Okay.
That's what they said. It was the tire store, so I don't know.
I got you. So, yeah, we're at Danner's shop working on a 08 Dodge Charger with some lighting that is out on the left headlight, and apparently it was at a tire store, and they said the bulbs were fine. That's where we're going to start. I'm not going to bother Caleb looking up diagrams and all that stuff without doing some quick voltage measurements at the bulbs, at those circuits. But that isn't why we're here today. I'm a little bit hesitant really about having this one even filmed. I don't know where this is going to end up. I mean, I guess all of this stuff that we bring to you guys is good. So for those of you that have not been with me before, my name is Paul Danner, my son Caleb Danner behind the camera, and we are at my brother James Danner's garage in Bethel Park, Pennsylvania, working on some cars. So step one on this, Caleb, voltage measurements. If I can get to those sockets easily on this circuit. I'm gonna grab my test light, maybe my voltmeter and a light, and I'll get you guys on here in a second. So move this air cleaner box is probably the best way to do this, I guess. Did you have this headlight assembly out, Danner?
They must have.
You think I should pull this air box out of the way, or does this whole assembly come out? I'm thinking if I pulled the light like that bolt, but then this bracket would be in the way of here. I wonder if I just pull pull that box out of the way. All right.
That 10 out.
Yeah.
All right, so you're taking that out?
Yeah. Hey, real quick, I want to talk about this shirt I'm wearing. I just redesigned some of the merchandise we have with the SD on top and the lettering, so we call this stacked. The ones that are on Teespring right now, we redesigned this logo a little bit. The newer one's a little bit bigger logo, so the SD is bigger, the wording is bigger. And this shirt that I'm wearing right now is the premium tee, and you see the length of it, it's an XL, and I've had this shirt over a year now. It's been through the wash countless times, washer, dryer, not being careful about, you know, making sure it doesn't shrink, and it's been perfectly fine. I cannot say the same thing about the tri-blend version. I think this one's like 23, the tri-blend's like 25. I like the tri-blend fit, but I have two different versions of the tri-blend. One did not shrink and one did. Yeah, so I
have one that shrank kind of weird.
Yeah, come up here so they can see the one you're wearing.
Right here?
Yeah, so that's the premium version too.
Premium. This is a large.
That's a large, okay.
Yeah.
And you're like 6 foot.
Yeah.
Yeah. Wow. So I don't know, just something to guide you guys. So looking at the wiring, this bulb is out, and there's another marker light that you're not going to see on the camera that's on that side, and they share this wire. So these two wires are shared between this parking light bulb here and the parking light bulb on the other side of the headlight. And then this one also has more wires going to it because it's also a turn signal. So this one's turn signal and parking light, and it looks like the outer one is just a parking light. So we can do voltage measurements here right at this connector is really where we're gonna go. I'll just do 3 quick measurements right there, just maybe even use my test light. One of the things I really like about my red bulb test light is it has a threaded piece. Is that still in focus?
Yeah.
And then I can put a T-pin on there, which is going to allow me to back probe that. Just checking my light, making sure I have a good ground. One of the things that my rookie students at the school will miss is that step right there. Now, knowing Chrysler for over the years, typically the black and the blue stripe is ground. They've used black with a blue stripe on all their sensor grounds forever, so I'm guessing that these are the two turn signal and parking light circuits, and then that would be my ground, I think. Yeah, so brown. So see the brown on this side, and the fact that brown is shared between this bulb and the one you guys can't see, which is off of this harness the other direction. That's going to be my parking light circuit. This should be the parking light circuit right here, and it's lit. Okay. So let me. Is that bulb still in the shot? I'm going to turn the parking lights off. That light should go out.
It went out.
Parking lights on, lights are on, so we have power. This is going to be really basic. And then the turn signal circuit then would be the one up from that. We'll check the ground last. I'm suspecting a bad ground, or we just got some bulbs that are out. We'll see here in a minute. This should be the fact that that's lit is not good. I don't have the turn signals on. That's suggesting to me a bad ground. The fact that that's lit, the parking light circuit might be back feeding through the turn signal, maybe. Let me see if I can make the turn signals blink. So I turn this left one on, nothing happens. Yeah, and that turn signal is on. We're clicking.
Yeah, nothing. Just stands solid.
Interesting. Well, that's possibly, let me turn the parking lights off. And so that should be the turn signal circuit. That shouldn't be happening. Now, if I turn my left turn on.
All right, now it's blinking.
Yeah. We got a bad ground here, people. Classic bad ground. In fact, the turn signals work with the parking lights off. Come here, get a shot of this. And this has nothing to do with my test light. So that's turn signals. Stay there. I'm gonna take my test light out. Test light's out of the picture, okay? Not connected. Turn signals are working. This is just a bad ground. And then watch what happens when I turn the parking lights on. We're gonna lose the turn signals and everything. Watch, whoops, sorry. Parking lights are now on.
Turn signals are off.
Turn signals are off. Turn the parking lights off. Turn signal works. Turn the turn signals off. Right? Nothing. Turn the parking lights on, and we have no parking lights. But back up here, that is the parking light circuit. Parking lights off, parking lights on, parking lights off, parking lights on. Right?
Yep.
This is a bad ground, Caleb. So what we have is the circuit is back feeding between the parking light and turn signals, and that's why it's able to work with the parking lights off. That's why the turn signals are able to work with the parking lights off, because we're back feeding, finding a ground through the parking light circuit. So I expect to see this ground be lit right now. And if I do, then our problem is in the harness that way. If I don't, then our problem is right in here. Okay? So now I need to load that circuit. I know we're using a test light. I'm going ground to ground. And so when I turn my parking lights or turn signals on, that light should not light at all.
It's lit.
So we have a bad ground. This is like classic voltage drop testing, classic voltage measurements. This is something that will trip a lot of people up because of the back feeding of the circuit. What we'll try to do for you guys is we'll pull a diagram up so I can explain what we just saw there within the turn signal and parking light circuit. Now right now, if I give that a ground, everything's gonna work. I'm gonna do that. I'm confident that this is that this is the ground of this circuit. I hope. Because I don't want to ground a power feed, I'll blow a fuse. No, that's absolutely the ground. And I know that because the brown wire was my turn signal circuit, which is shared between this bulb and that bulb over there. I'm sorry, the brown wire is my parking light circuit. And the outer bulb that only has 2 wires, we've already confirmed the parking lights here, and that means the only other wire is the black wire, which is the ground, and that's tied into the one we are on. I could also, let's see if I can make that one blank. Let's see, hold on. Parking lights off, left turn signal on. Yeah, so that's blinking because it's a ground, an intermittent loaded ground because it's a parking light circuit. If I move up to here, see that one's blinking as well. There's another way to confirm before I ground this circuit. What I'm thinking about, I'm confident that I was on the ground, but I'm thinking about you guys here. You don't want to ground something that you're not sure. So if we unplug the circuit unplugged means we can't load this ground anymore. What we're going to see now is this top wire is going to be blinking. The one that we said is our turn signal circuit. And the bottom wire is not going to be blinking at all because it's unplugged. Circuit's not loaded, right? How do we load the circuit? You keep it plugged in. Circuit's loaded. That is a ground. That's a wire that should be grounded. All I'm going to do is connect this from there, and we'll go right to, you stay focused there because you're going to see this light's going to stop blinking. I'm going to go right to something metal here. I'll get a shot of where I'm at in a second. I'll go to this aluminum housing here. Okay. Notice that light went out. Come up here, Caleb. Come up here, take a look at this turn signal. Left turn. That's with the parking lights off. Here's with the parking lights on. We should have a parking light circuit and a turn signal, just like it's supposed to be. We just got a bad ground. This is a nice, easy one. Well, it's only easy right now as far as identification goes. Now, where is that ground bad is the question. So I don't have the turn signals on right now, and both bulbs, this is on and this is on. So they both have a parking light. Yep. And then when I turn the left turn on, this one's only parking light. This is parking light and turn signal.
Yeah.
Okay. And they share a ground. These bulbs share a ground. So essentially what's happening is the turn signal circuit is backfeeding through the parking light bulb, and it's finding a ground throughout a different path on the car with the circuit off. Let me take the ground away. We got nothing with the parking lights on. Just want to make sure we, as I'm doing this later, that we get our theory correct. Yeah, so this proves it right here. This is not a turn signal circuit. It shouldn't be blinking at all. Why is the parking light that should never blink blinking? Because the turn signal is finding a ground through the parking light circuit, not within this assembly, but on one of the other bulbs. It's going back feeding through the ground wire of the parking light bulb and into the feed wire of the parking light bulb and finding a ground elsewhere on the car. And that goes away. We lose that path when we provide power back to the parking light circuit. So if I turn the parking light back on right now, stay there, watch what happens as soon as I turn the parking lights on. Parking lights are now on. Gone. Gone. That's because we've taken that back feed out. This is a back feed. All right, I need to stop talking, find the bad ground, and then we'll put the theory in behind it. And so this is going to be pretty simple. Should be. And that is, that ground should not be lit ever. That's a loaded circuit right now, which is perfect. Just like what we've done in the past, I am first looking at this harness for damage. And we need to backtrack, so it's going to go this way. I want to look at my contact points. There's a contact point right here, right on the metal of this part. Then it comes underneath here. I don't like that crap under there, contact point there. And we'll just keep our test light there as our guide. Contact point here. There's a contact point right there. Going back further this way. Ooh. Don't like that one right there. It looks okay. I moved it out of the way, nothing there. I mean, really what you could do in a case like this is you could just run a ground wire off that circuit, and we may end up doing that. I'm not going to chase the harness for a long period of time, but if you're in the field, what you'd want to do is you want to make sure that there's nothing else on that circuit, because sometimes if you bypass a wire, you only fix half of a problem, a known problem. There might be another problem that's not working that's tied into this same ground. It would be helpful for us to have a diagram right now. I'm going to do one more quick contact point visual inspection, then we'll pull a diagram. But running a wire is an option. And I see some here, come over here. He just shot inside this inner fender. There's red from this angle over here. There's red numbering on the inner fender way in there. See the numbering?
Yep.
That tells me that this thing's been in an accident.
Oh yeah.
Well, the inner fender has red pen like numbering on it.
Oh.
Right? And then some other things that we want to look at would be these guys here to see like the bolt holes, to see if they moved at all. See how the tops of the bolts are they've been messed with. See how this is painted? Mm-hmm. And then those ones down there. Yeah. That kind of tells me this has been off. I think our damage is in here, Caleb. I do. You got your knife on you, Caleb?
Yeah.
All right, so black with a blue. That's pretty heavy duty black and blue right there. Yeah, and there's a ground point right here.
I see it. Got it.
And that's where a lot of those are gonna probably, it might go just right to that. So all these black and blues, they go right there. So we're not gonna be going far in this harness, I don't believe. The question is gonna be which one of those. I'm just gonna do a measurement on one. We may have multiple bad grounds here for, you know, all these other circuits. So I'm just gonna hook one to a measurement right here. There we go. So that is this whole island. Guys, this is why, right here. This is why we don't run new wires. I know some of you are thinking, right from the get-go, as soon as I found that, just run a new wire. Why don't we run new wires? Because I have a whole bundle of grounds that are bad. There are other stuff, there are other things that don't work right on this car. They didn't complain about anything else, Tanner. Like various electrical problems. I mean, we have a main bad ground lug on this.
Really?
Look at this. This ground lug right here. Caleb, get a good shot of that. That ground is bad right there.
Got it.
And look at all the grounds that go to it. All of these grounds go to that. That should not be lit right now. I'm just gonna.
You're reading power on the ground.
Yes,
side.
yes. With the parking lights on. Now, one more shot, Caleb. I'm gonna go to a different wire on this same assembly. I'm gonna show you that this whole circuit's bad. This is a totally different wire. Oh, it's not. Did I get lucky? Did I get lucky and it's only one.
Well, try some others.
Wait, hold on. That's the real big fat one is good. Well, actually, that circuit isn't loaded either, but this is the first one I went on. I can't believe I got that lucky. I mean, so let's talk about this for a second.
Yep. Our
ground is bad in which direction, Caleb? Is it bad going to the left into the harness, or is it bad going to the right? Remember, this is a ground wire, and it's coming from the parking light circuit. It's coming from there, and it's going this way, and it goes to that eyelet.
Yeah.
So my question to you is, it's lit in this location.
Yeah.
Is my problem that way, or is it that way?
Well, if it was bad that way, more would be lit, correct?
Well, think about it. The circuit grounds to that stud. We know that now.
Yeah.
So the fact that it's lit all the way to here tells you the integrity of the wiring is good all the way to that point.
Yeah.
And your problem is that way.
Oh.
It's that way.
Okay.
Let me check a couple more of these. Some of you are thinking to yourself, well, you're poking holes in that wire. You can't poke holes in wire. Is this ground, for those of you that are mad about me poking holes, is this an exposed eyelet? Yes, it is. Am I damaging a ground wire that has an exposed copper piece way just to the right of it by poking tiny holes over here? No, I am not. And these are ones, because they're ground wires and they're right at the end of the circuit, I'm not even worried about fixing them. I'm putting really, really tiny holes on an already open circuit. I can't believe it. It's the only one that's lit. I was wrong about the eyelet itself being bad. That one's not lit. I'm taking my time here, guys, because I want to show you the exact fault. Okay? If I'm working in the field, I'd be moving a little bit differently. That's not lit. Not lit. So how's my eyelet? Not lit. Remember, loaded circuit. I have the parking lights on. Not lit. The big heavy one, I know I checked.
I'll actually get the car in and then write it up. I gotta
So that's the only one that's bad. That is so odd. That is so odd. Is that wire broken right there? It's just making bad contact on this corroded piece. So it wouldn't be, there's no reason for me to take this off and clean this up, because if this was bad here, what would happen is the parking light wire, it would be going in. This is basically a power right now because there's no ground. It's got 12 volts on it. You see my lights lit. It would be lighting all these other ones too if this eyelet was bad. And so it is not, it's just like bad in that location. It's weird. See what I just did?
Pulled it out.
Yep, I broke another one too. That's okay. That whole eyelet probably needs to be replaced. But we'll maybe put an eyelet on this, put it over top. I don't think I have one big enough for that. Let's see what Danner's got. Well, for now, do this. Parking lights, turn signals.
Still blinking fast.
Good now. It shouldn't be blinking fast at all. I think that was just the initial one.
I think so too.
So that's the turn signals off, turn signals on. It's not blinking fast. That's just the residual. I bet you there would be fault codes too, potentially. Maybe. I don't know for sure. Don't care. I'm not putting the scanner on this. We just need to fix that eyelet. I think we'll do that. Probably end up just putting another smaller one there. Here, I'll just kind of prove a point here with my ground. We're gonna go right to this stud with my jumper wire. The parking lights are on. In fact, what I'll do even better, just so you guys are gonna see, I'm not touching that bolt yet, because I know some of you are gonna say it was because of that. I might have to touch that bolt to do another eyelet over top, but see how I'm clipped to this and I'm clipped to this, right? My two wires that broke off when I pulled on them, and then I'm on here. So proving that this ground here, from here to this housing, is good. Check this out. We have lights. I'll show you again. There's parking lights. There's turn signals. Okay? That eyelet was not bad. It was never bad. If that eyelet was bad, all my parking light circuit be feeding in no ground at the eyelet, and it would backfeed the rest of those ground circuits. So we really only had one circuit affected, and it was the parking light circuit, but it's still a good lesson. I wanted to say this is why we don't run new wires, because you find something like that, and then imagine if that eyelet was bad and you ran your own ground to that circuit. You would potentially overload the circuit because you got one small strand, not realizing there was 6 more wires that are sharing that ground. That'd be one side of it. 2 would be you maybe fixed the parking light turn signals, but you got a whole bunch of other circuits that aren't working. That's why I don't like to run new wires. I want to know exactly where it's bad. I have on occasion done that, but I want to do as much research and homework as possible before I would ever do something like that. All right, so I'm comfortable with that eyelet. I'm not going to redo that whole thing. We're just going to put a small one on there and bolt it right to it. Use that one, or I'll use this one based on the size of the stud down there. I think I'm going to use this smaller one. And I know some of you are thinking, well, it's not insulated. You're right, neither's the factory one. Look, it's not insulated. That's copper right there. I'm not worried about it. It'll be fine. It will be fine.
I can see the parking light turning on as you're messing with it.
Yeah, I still have the circuit on. Well, this makes sense that they didn't have any other complaints of any other circuits working too. If this eyelet was completely bad, it would definitely have caused some other issues. I think an ideal repair would be to change all of these. This is actually my next door neighbor's daughter's car, so I can promise you, if they have any other issues, guess what Caleb and I are going to be doing in my driveway? Replacing that whole eyelet. All right, look up here. Last time on the bulb. Good.
Parking lights, yeah.
Okay. Turn signals only. Parking lights only.
Yep.
Parking lights, turn signals.
Yep.
Okay. So we're done. I mean, we need to talk about the back feed, and I think I could probably draw that for you guys rather than looking up a circuit. That would just be easier. All right, so we'll do parking, right? You're gonna have a feed come down. It's gonna go to all 4 corners, but I'm just gonna do the one, right? So this would be the right front that was working. And then that's going to come over to the left front. And then we have parking light, and I'll do turn signal like that. They share a ground. Turn this ground. Got to get the rears in here. Your parking light is going to have a ground somewhere in the back. And those rear ones might be shared as well. The point is, the rear parking lights are going to have different ground locations than the front ones. This is your front ground. The one we were messing with, where the wire was bad, is right here. Okay? So if this ground is bad, which it was, is open right here. When you turn the parking lights on, parking lights have no, let's see, the parking lights didn't work at all, right? And the turn signal worked. So I'm not drawing the turn signal circuits. That means the parking lights for the front coming this way. Make sure I have this right. Just gonna draw the parking light power. Parking light P, parking light P. This is turn signal T. Parking light P, P, P. Okay? The rear ones, they worked. The right front, oh, I did that wrong. Right front, this is a different ground. This is wrong. This one worked. This is on a separate ground. This is not here. Because the right front worked. It's the left front that did not. I didn't draw the turn signal for the left front. But here's what's happening. With no ground on this bulb here, this whole leg is dead. So this circuit here in dark, we'll draw it in dark black because it never had a ground. Okay? So this leg was totally open. Okay? But because the turn signal bulb shares a filament, this is one bulb right here on the one, and this is your other bulb. This is your single bulb. Because it's shared, when you turn the parking lights on, there's no ground, so nothing happens, and there was no backfeed through the turn signal circuit. When we had the parking lights off, and we turn the turn signal on, power comes this way, right? Comes through this bulb, which is a lower ohm, brighter bulb. And with that, it is looking for a ground here, but it can't find it. So where does it find its ground? Watch. As long as the parking lights are off, it finds a ground through this bulb on its way to what?
Parking light circuit.
This parking light circuit, or this parking light circuit, or this one. And the reason why it looked like it was a little bit dim too. The reason why it was dim is because it's got to go through a filament here and a filament here or here before it can find a ground. So it wasn't really a full ground.
And it was blinking that parking light too at one point.
It was blinking that parking light because as the turn signal is blinking on and off, it's lighting this bulb, but it's also lighting that bulb on and off. So it was both bulbs. Oh, I'm sorry. And it was lighting this bulb because this bulb had no ground either. So both of those were blinking, right? You couldn't tell from the inside because this is the same bulb, but it was going through both, but it was blinking this bulb again because of the bad ground. Can you picture that?
Yeah, that's what I was
Yes. So
about.
Turn signal comes in, there is no ground, so it can't go this way, back feeds through this bulb, comes back over here, back feeds through this bulb, or it would split and go in. Actually what it was doing, Caleb, is it was going in the ground wire. It was the ground, remember the ground wire was blinking too. When we had our test light here to ground, our test light was also blinking on and off. Yep. So the reason this one was blinking on and off is we were back feeding the ground, and it was finding a ground through this parking light bulb, was finding a ground through one of the other parking light bulb circuits. The reason nothing worked when you had the parking lights on is you're taking that ground away. You're taking the potential of it finding a ground here, here, or here away, because now we're feeding power in here, and then no ground for the parking light circuit, no ground for the turn signal circuit, so power coming in for the turn signals has no way to backfeed because the parking light circuit is active. Does that make sense? Mm-hmm. Are you sure?
Yeah.
That's why, guys. Backfeed, very, very easily missed. Make sure when you're doing ground to ground testing, even if you're using a test light, you can do that. You just need to make sure the circuit's loaded. How do you load the circuit? Well, in this case, turn the parking lights on or turn signals on. Yeah. Circuit's loaded. Do your voltage measurement. It shouldn't light. Bad ground. Classic, bad ground. Special thanks to my son Caleb behind the camera. Special thanks to my brother for letting us use his shop. Yeah. Classic bad ground. Cool. Make sure you check my playlist out for bad grounds. I'll put this under there. Thanks for letting me use your shop.
Yeah, man, it's your neighbor's car, man.
Well, that's what I told.
Charge him anything.
That's what I told. That's what I told Caleb too. Is we will be seeing, if people don't like our fix, it don't matter. If it comes back, guess who it's coming back to? I'll be fixing it in the driveway. Guys, if you need more training about stuff like this, again, the playlist I'm gonna put this video under, make sure you watch those other bad ground videos. I have a bad block ground, I have a bad computer ground, I have a bad fuel pump ground, all different circuits where you can see stuff like this. Also, I have my premium channel on my website. It's www.scannerdanner.com. I have right now about 410 videos on that channel. Hundreds and hundreds of hours of classroom lectures, exclusive case studies, where I really bring you into my classroom at Rosedale Technical College and teach you this type of stuff. Foundational, fundamental electrical, electronic testing. and it's 11 bucks a month. You cannot find a less expensive education anywhere. $11 a month. You can't even get a cup of coffee for a day, per day for that. It's like 36 cents a day is what it boils down to. So you can't even get a cup of coffee per day for what I'm offering. Skip your coffee on the road, make your coffee at home, and join my premium channel. You will not be disappointed. Ask around. People will tell you all over the world. People will tell you what it's doing, changing their lives. Thank you guys so much. Again, thank you, Caleb. See you next time.